In this video, we are going to talk about trigonometric identities. So let's talk about trigonometric identities. So in order to talk about trigonometric identities, what I'm going to do, I'm going to consider a right triangle. So let's consider a right triangle. So this is my right triangle A, B, C, and the triangle is right at C. I should say vertex C. So we all know that side opposite to A is small a, side opposite to B is small b, and side opposite to C is small c. Now, if I consider A as my reference angle, then this will be my what? Opposite. This will be my adjacent. And this will be my what? Hypotenuse. Right? So what we are considering a right triangle ABC, right angle at C, then the side opposite to A is A, opposite to B is B, and opposite to vertex C is C. And of course, I'm taking my A as my reference angle. So this will be my opposite, this will be my adjacent, and this will be my hypotenuse. So what will be the value of sine A? Let's write sine A. My sine A would be opposite over hypotenuse, which means what? Sine A is equal to, my opposite is BC over my hypotenuse is AB. Right? So this is my sine. Now let's talk about cosine. What is my cosine? So my cosine of A is, cosine is adjacent over hypotenuse, and we all know that my adjacent in this picture is AC, so I will write AC over my hypotenuse is AB, so I will write AC over AB. So this is my cosine. Now let's talk about tangent. So my tangent of A is basically opposite over adjacent, which means what? Tangent A is basically, my opposite is BC over my adjacent is AC. So my tangent is BC over AC. So as you can see, I got my sine A, cosine A, and tangent A from this triangle ABC. Now let's talk about Pythagorean theorem. Pythagorean. Let's talk about Pythagorean theorem. What was the Pythagorean theorem? And if I remember correctly, Pythagorean theorem was a squared plus b squared is equal to c squared. Right? Now, if you look at the picture, what is my small a? My small a is BC. So, can I write this small a as what? BC squared plus this small b is my AC. So, I can write AC squared, that is equal to, my small c is AB. So, I will write AB squared. Right? Now, what I'm going to do, I'm going to divide both sides by AB squared. So, I'm going to divide both sides by AB squared. So, as you can see, I'm dividing both sides by AB squared. And if you look closely, my first term is BC over AB, and it's a square term. So, I can write the first term as BC over AB, and everything is inside the bracket whole square, right? Because as you can see, I have a square at numerator and denominator. So instead of writing two squares, or I should say two separate squares, I can combine it together and write it like that. In the same way, I can write AC squared over AB squared as plus AC over AB whole square inside the bracket. That is equal to AB squared over AB squared. So, if you look closely, my numerator and denominator is same. So what I can do? I can cancel it out. And if I cancel it out, what will happen? AB squared over AB squared is basically what? 1. Right? Now, let's look closely. What do I have? I have BC over AB squared plus AC over AB squared, that is equal to 1. Now, let's look at these three formulas and see which formula belongs to, or I should say, which trigonometric belongs to first term. So, BC over AB. Okay, right here. BC over AC is basically what? Sine A. So, can I write this one as sine A? Of course, why not? So I can write sine A, but wait a minute, I have a square term outside because BC over AC whole square. For BC over AB, I am writing sine A and then I have a square term outside. Plus AC over AB, and if you look closely, AC over AB is basically what? Cosine A. So inside the parentheses, I will write cosine A whole squared, that is equal to 1. Now, if I simplify further, I will write sine squared A plus cosine squared A is equal to 1. And this is our first trigonometric identity.